right, we have this way to model Mendel's laws. It's called a Punnett square, and we use Punnett squares for predicting what the offspring will look like. And we can do this for different types of traits. So let's say that we want to crossbreed two rabbits, and we know that the first rabbit is homozygous dominant and the second rabbit is homozygous recessive. So what we'll do is we'll take those parent alleles and we'll place them above the Punnett square and on the side of the Punnett square. And it doesn't matter if you put the mom's traits on top or the dad's traits on the side. You just choose and you put one set of traits on the top and one set along the side, and then we fill in these squares. So we would bring this bee down and we would bring these bees over. And again, we would bring this bee down and these bees over. And you notice in this situation, 100% of the offspring are now heterozygous dominant. So we would have 100% of these rabbits would have black fur. We wouldn't see any of the white fur show up with this cross. So let's try a different cross. Let's try this one where we have a heterozygous for the black fur and we have the homozygous recessive. So again, the capital B comes down, the lowercase b comes across. This one, the lowercase b comes down, lowercase b comes across. We have a capital B, lowercase b here, and we have the two lowercase b here. So this situation would give us 2 of the offspring would be heterozygous dominant and 2 of the offspring would be homozygous dominant. So we can look at that in terms of ratios. The ratio would be 2 to 2, and we would simplify that. That would be a 1-to-1 ratio. Or we could say what percent of the offspring would have the heterozygous genotype. That would be 50%. Or we could ask that question in terms of what percent of the offspring would have white fur. And we would say, okay, well, the white fur has to be the recessive alleles, so 50% would have white fur. So we'll do one more example of a cross. We'll do the heterozygous with heterozygous, so that would be capital B here, lowercase b there, capital B here, lowercase b there. We're going to bring those into the Punnett square. And what we see is we have 1 homozygous dominant, 2 heterozygous, and 1 homozygous recessive. So when we're looking at this, we can talk about this in different ways. If I say, what is the genotype ratio, then you're looking at the letter combinations, and you would say, okay, well, we have 1 that is homozygous dominant, we have 2 that are heterozygous dominant, so we have to use that 2 there, and we have 1 that is homozygous recessive. So this would be our genotype ratio. If we're talking about the phenotype ratio, that's going to look a little bit different, because the phenotype would be what's going to be expressed, and we can look and say, okay, well, this will express the dominant trait, this will be dominant, this will be dominant. So that's 3 that are going to express the dominant trait, and we have 1 that's going to express the recessive trait. Neil, be quiet. My dog's whining at me. And so this would be our phenotype ratio. Now, most of the time, when you're working on these Punnett square problems, you're going to be given a scenario. And so instead of them actually telling you what these letter combinations are, they would give you a scenario here. They would say a rabbit that is heterozygous for black fur is crossed with a rabbit that is homozygous for white fur. What are the possibilities in the offspring? So you would have to say, all right, heterozygous for black fur is going to be capital B, lowercase b, and homozygous for white fur is going to be lowercase b, lowercase b, and then you would do your cross and you would figure out your possibilities for the offspring. Now we can also do a dihybrid cross on a Punnett square, but in this situation, students tend to make some mistakes here because they automatically want to start out with just putting these traits on to the squares here, because they'll say, all right, well, there's 4 letters here, so we'll just put the 4 letters across here like this. And then they do the cross and it doesn't work out and they're confused as to what went wrong. So what you have to do instead is you have to look at what are the possibilities that could be passed along in these alleles, okay? And this, it's kind of like the FOIL method in math, okay? So what you have to do is you have to say, okay, well, we could have a capital B and a capital S. That's one possibility. But we could have the capital B and the lowercase s. That's a second possibility. And then we could have a lowercase b with a capital S. But we could also have the lowercase b with the lowercase s. And those are our possibilities, and so that's what we're going to put along the top of our chart. So here we have capital B, capital S, capital B, lowercase s, lowercase b, capital S, and lowercase b with a lowercase s. And then we do the same thing for the other parent. Now notice that these are the same letter combinations as we had in the first one, so our possibilities are going to be the same. So we're going to put those same possibilities on the side of the chart here. And then we're just going to go through and we're going to start filling in this chart. So we bring the top down and the side over. Bring top down, side over, and I'm going to skip ahead so I can clean this up a little bit, and voila, it is all filled in for us and looks all nice and neat. And so now what we can do is we can look at ratios here. We can see which ones are going to have black fur and which ones are going to have white fur. We can see which ones are going to have long fur and which ones are going to have short fur. One of the things we look for right away is, will we have any rabbits with white long fur? And since those are both the recessive traits, we can see that we have one possibility for that. But we can look here and we can say, all right, this is going to be both dominant traits. This is going to be both dominant traits. Anytime we have a capital letter for the trait, it's going to be the dominant traits. So we can look through here and look for capital letters and see which ones are going to show the dominant trait. When we look for lowercase, we can say, all right, well, this one is going to be canceled out by these capital letters. So the only time that you would have the recessive trait is if both of them are the lowercase letter, like in this example.